Hello and welcome to another edition of 0 to Hero in Python programming. Today we'll be treating lists in Python. So a list is a value that contains multiple values in an ordered sequence. So the term list value refers to the list itself, which is a value that can store in a variable or pass to a function like any other value, not the value inside the list value. So what we mean is this is a list, not the values inside a list. So how do we write a list in Python? Basically, we use square brackets to begin and end the list, and we separate the items in a list with a comma. You can put the option of space if you like or not. You might not put space, but the comma is the separator of a list. So if we run this, we have that list. Then we run this, we have that list. So you can put integers in a list, you can put strings in a list, you can put tuple in a list. Okay, we've not even done data type called tuple. You can put boolean in a list, you can put none, which is a non-type of variable in Python, in a list. Every other type of data, you can put them in a list. So that's that on that. And you can mix them. For example, here we have string, we have float number, we have boolean, we have none, and we have integer. Here, okay, we can then assign a list as like a variable, like spam equals cat, bat, rat, elephant. So if we run spam now, we have cat, bat, rat, elephant. So getting individual value in a list. So you might remember what I said here, in an ordered sequence. So in a list, the first item that comes will take the first index, second index, third index, fourth index. And mind you, counting in Python starts from 0. So this is index 0, index 1, index 2, index 3. So basically we run spam 0 now, we get cat. Spam 1 will give us bat. Spam 3 will give us elephant. So if we, for example, this one now we say cat, bat, rat, elephant. So if we run this, it will give us what? 1, 2, 3, 4. So we start from 0. That's 0, 1, 2, 3. So it will give us elephant. So that's that on that. Then this string concatenation that we did before. So if we say hello spam 0, it will just give us hello cat. So we can, okay, now we can find the, okay, we can call indexes. If the index does not exist in the list, it will give you list index out of range. So for example, we are running index 10,000 here and our list is just of length 1, 2, 3, 4. So it will give us an error. So in fact, if I run index 4, it will give us error too, because we start counting from 0, so it stops as 3. So if I run this, it will give us error too. So let me just undo what I did. So we have our, and if we even index it with is a float number, to give us error, except we convert this back to an integer. So if we convert it to an integer here, it gives us bat, which is the one in index 1, but to us that's second position. So that's that on that. So now that, you know, when I was talking that time, I said we can have list in a list. So this list in a list now, this is another list in a list. So here we, if they ask anything about this list now, we have index 0, index 1. So you know, remember, we don't count what is inside the list of a list. A list is separated by a comma. So it is from this comma that will stop the first one, then this, it ends. So that's 0, 1. So spam 0 will give us cat and bat. Abi? No, okay, I didn't run this. So spam 0 will give us cat and bat. Then we now go the list inside the list, that's spam 0, which is cat and bat. Then 1, it will now give us bat. So if I run this to give us bat. 1, 4, that's 0, 1, then 4. 1, 0, 1, 2, 3, 4, it will give us 50. So that's that on that. Then the negative indexing. Negative indexing is just like, instead of you starting 0, 1, 2, 3, you can just start -1, -2, -3, -4. So if you run -1 here, spam, okay, I didn't run this. Let me just run that. So to give us elephant, we run spam -3 to give us 1, 2, 3, to give us bat. So that's that on that. Then we can concatenate our what we get from our list with a normal string, the way we normally do with strings. But mind you, It's not like print that will convert your integer to a string. If it's an integer you want to add to a string, you have to convert it back to a string first before you add it to a string. Just have that at the back of your mind. Then getting sublist from a list, for example. Now let's say this is a list. You can get our sublist like spam 0 to 4 now. So 0 to 4 will be 0, 1, 2, 3. 0 to 4. And in Python, we don't count the last position. So this 0 to 4 means 0, 1, 2. 0, 1, 2, 3. We won't count 4 as part of it. So if you run this, it give us the whole list itself. If you run 1 to 3 now, it will now give us what? 0, 1, 2. So it will give us this and this alone, because there is no 0 here. We just have 1, which is this, and it will not count the last one. So it will stop at 2 instead of the 3. So if you run this, give us bat and rat. So 0 to -1. Remember what I said the other time? 0 to -1. -1 is the ending, then 0 is the beginning. So it's like you are printing the whole list. And mind you, it will not pick the last one. So it will stop at rat instead of getting to elephant. So you get it like that. So this one too. Okay, if you don't put anything in the beginning, it means you are starting from the beginning and end at 2. If you don't put anything at the end, it means you are starting from whatever you write, the index you write here, and end at the end. So this will give us cat to bat. It will not count 2. You remember, it will not count the last one. Then 1 to the end. So this one will give us bat, rat, and elephant. So this one will give us the whole list, 0 to the last distance. So you can check the way you check the length of a string, you can check the length of a list. So the length of this list is 4, and you count 0, 1, 2, 3. But if you count like normal human being, 1, 2, 3, 4, which is the length of the list. So then changing values in a list. So for example, you want to change, let's say you want to change the first position, that's 0, 1. You want to change it to arcvac, addvac. So just do that. If you print spam now, it has replaced the one in the first position with this, which is 0, 1. So it has replaced bat with this. So same thing here. You can now say, okay, for example, spam 2 equals spam 1, and you've labeled your spam 1 to be this. So if you run this and check again, you see 1, 2 has changed to this. So that's that on that. Then you can just say the last one should be 1, 2, 3, 4, 5. Then if you run it, so that's replacing value in a list by index. So concatenation and list replication now. So it's something like we added strings the other time. So if you concatenate strings, this is what it will give you. If you replicate that the way you replicated strings, this is what it will give you too. So that's about that. Then removing value from a list with delete statement. So if you delete the value in position spam 2, if you run it now, the value in spam 2 has been deleted. So the new value in spam 2 is this 1, 2, 3, 4, 5 now. So if you now run this and check, you can see 1, 2, 3, 5, 5, 2 is gone. So you can see as soon as this one is deleted, something else take that position, because we have sequential arrangement in list. So if you delete the whole list itself, it means you won't see it in existence again. So if you run spam now, tell you spam is not defined because you deleted the whole list. So be careful while running your code so that you won't delete what you are still using. So now working with lists, this is where the programming aspect of things starts. You know, before we did list, if you were going to write the names, let's say the names of your cats now, you say cat 1 equals this, cat name 2 equals this, cat name 3 equals this, to the last number of cats. Mind you, I don't have cats, not talk of having 6 cats. So in case you are thinking I have cats, those are not my cats. They're just examples. So here is another one here. So let's say you want to start imputing your cats the way we did impute that time. Let's say our cat, let me just make it simple. Puka, Zoe, let's just go Joy, Khan, Ruth, Shola, Eminem. So your cats are Puka, Joy, Khan, Ruth, Shola, Eminem. So you can do the same thing with now a while loop and saving your data in a cat, in your list cat name. So if you run this now, to start asking you for the name of your cat, and it can only break when the moment you press enter and you don't input any name of the cat. So let's do it. Puka Shola, Khan, Ruth, Joy. Let's just end it here. So the names of our cats are Puka, Shola, Khan, Ruth, Joy. So you can add with as many cats as you want to that list. So using for loop with a list. You remember when we're doing lists the other time, we're using range, and I said something about, okay, to use it even more efficiently, we can bring in a list to it. So this is a list now, using for loop with a list now, or even while loop with a list. So for example, for I in this, so remember we start counting from 0. So for I in this, it will be like saying for I in length of this range, print what is inside this range now. So the same thing as 0. For I in 0, 1, 2, 3, print I. So it will be, first time it take the position of 0, print it out. Second time it take position of 1, print it out. Third time 2, fourth time 3. So like that. So now let's say this applies. We have pen, we have stapler, we have flame thrower, we have binders. So if we say for I in range length supplies, print index string I. So that's the position the I is taking at that moment is in supplies is supply I. So we're now saying, you remember the way we're calling this thing by the indexes. So this I is the index is taken in this length. And remember the length of this our supplies is 1, 2, 3, 4. So it's 4. So if we run this, it will take the position when it's in 0, is index 0. Remember Python start counting from 0. Index 0 pens, index 1 stapler, index 2 flamethrower, index 3 binder. So using the in and not in operator now. So if you are checking, is Audi in this list? Yes, it's in. So that's true. Okay, let's now have a list called spam again. Then is cat in spam? No. Is Audi in spam? No. Is cat in spam? Yes, that's true now. So you can see Boolean operator coming in here again. Then this is another type example of list. So print enter a pet name. But I could have actually reduced this by just removing this, cutting it and pasting in here, so that we have more efficient code instead of using the print statement again. So if we run this now, so we want to check if you know the name of the pet in this list. For example, if I now write Puka. Puka is not in the list, so I don't have pet named Puka. But if I run this again and I write, okay, if I use capital letter Puka now, it will work. Remember, Python is case sensitive, so Puka is in my pet list. So that's that on that. Then multiple assignment trick. This is just basically the ability for you to actually assign, like, let's say names. Don't worry, when we get to dictionary, you get the gist of what's happening here. Like, let's say this is a size, this is a color, and this is the disposition. So for a list now, so you now write this, then you assign for position 0, say it's size, position 1 is color, position 2 is disposition. So you can do exactly what you did here. So in case you don't know what we are doing here, if you now come down here and call disposition, if you call color now, color will give you black because that's color, and that's in position 1 of cat. So if I now change cat to the position 1 of cat to green, the color will become green automatically like that. You can try that on your own. So here, instead of we doing this separately like this, you can just have them separated by comma equals cat. But mind you, the names you give each position variable must not be longer than the number of variables you have in your list. So if you run this now, it will work well. But if you now put name, which is the fourth thing in this list, in this naming, but it's not in this list, so it won't be assigned to anything, so it will give you an error. You can see the error it's giving you. Not enough value to unpack. Expected 4, got 3. So it's expecting 4 things in this list, but it got 3, so it can't unpack it for you. So this is your assignment for this for today. But for you to be able to do this assignment well, you might need to check our class for for the next lecture. So when you finish the next lecture, you can now attempt this assignment and the next lecture's assignment. Push to your GitHub repo and comment the link to your GitHub repo in the comment section below. See you in the next class. Bye bye.